Okay, so let us continue. I was saying that when you talk about a set, we mean that it is a collection of items. So for example, in your single issue, when you talk about cars, you can say that we have maybe Honda, Toyota, and Range Rover. So those three items, those are set of cars that you can find in Wasingishu. So when we collect all those items together, it is what we mean a set. And a set, the easiest definition is refers to the collection of items. Now, the items in a set, the item in a set, in a particular set, those items in a particular set are called elements. So elements are items in a set. So you can say the items in a set are called elements. So the items in a set are called elements. I hope my screen is clear. So, but we are saying that the items in a set are called elements. So they are donated with a bracelet. They are donated by bracelet, bracelets, and separated by comma. So they are donated by bracelets. So bracelets ni kama hizi zinakaanga hivi. So those is what we call them bracelets. So they are donated by bracelets or and separated by commas and separated by comma. You can also say, let me check. You can also say this one. You can say that you can also define, let us define it in another way. The meaning of the word set, a set theory, or a set. A set. Let me look for that definition. We have another definition, a very good one. Let me see if I will find it. So hopefully nitaipata. Now, so tumesema it is donated. So you need to remember that it is donated by a bracelet and separated by commas. So it must be donated by bracelets and donated by comma. Or we have another definition here. Another definition of a set you can also use. Here we say a set refers to arrangement of numbers or items, refers to arrangement of numbers or items which are enclosed within curly brackets full stop. Okay, and you say and separated by commas and separated by commas. So that's another definition that we can use. Example, let us give an example. A good example here, an example of a set, i.e. A is given by 1, 2, 3, 4, 5, 6. Now that one is a good example of a set. That one is a very good example of a set where A is our set. Our A is our set. Then the items 1, 2, 3, 4, 5, and 6, those are our elements. So the items in a set. So the items in a set are 1, 2, 3, 4, 5, and 6. So those are our elements. So the items in a set. Then they are enclosed in a bracket, separated by commas. So that's the definition of a set. So when you talk about a set, we are talking about collection of items, and those items. So those are the collection of items which are enclosed in a particular bracket, separated by a comma. Let us continue. When the items are interchanged, so when the items are interchanged, the item will still be there, and therefore the set will remain to be the set. So for example, so if the items are interchanged, so if the items are interchanged, the set will remain. So if the items are interchanged, so the sets will remain. So the sets will remain, and it will be like this. So let me write it. So it will be equal to. So for example, let us interchange A. So we have 6, 5, 4. Now, when we interchange, the items remains. So we have how many items here? 1, 2, 3, 4, 5, 6. So we have 6 items. When we interchange the items, we have how many items? 1, 2, 3, 4, 5, 6. So the item. The difference is that we have just interchanged the items. So we have interchanged the items, but the items are still there, and therefore the set will remain regardless of whether we change the item or not. So the item will still be there, and therefore when we interchange the items in a set, the set will remain unless we remove one item. So this one, so set A.
Leo 300 na saini nimemtuma. Sina do.
So set A will still remain to be set A when we interchange the items, regardless. So that is all about definition of a set. Let's talk about cardinality. Cardinality. So in case you have a question, you just type. I think that one would be favorable. Cardinality. Now when we talk about cardinality, we are trying to talk about the measure of the numbers of items in a set. So how many items are there in a set? So the measure of those items is what we call cardinality. So it is a measure. It is a measure of. It is a measure of how many elements. How many elements? It's a measure of how many elements. It's a measure of how many elements are in the set. Are in the set. Donated by. So this is what donates the measure of cardinality. A, and then into 2 lines in katikati sijui zinaitwaje, but we call it vertical lines. So 2 vertical A. So for example, a set A, when you want to measure the cardinality of this set A, so the cardinality of set A, for example, here tumeweka hapa juu, so it is divided by 2 vertical lines. So divided by 2 vertical lines. So how many elements are there? We count 1, 2, 3, 4, 5, 6. So we have how many items? 6. So in an exam, if they ask you to give the cardinality of a particular set, so a particular set for a set in an exam, so for you to measure the cardinality, for you to determine the cardinality, you remember it is a measure of the number of items in a set. Now, a set with no element is called an empty set. So hapa tulikuwa tukipeana example. Empty set, we say empty set, a set with no element. A set with no element. So a set with no element. Symbol donated by donated by, for example, we have a particular set here. So it doesn't have anything inside. So that one is an example. So it's an empty set, nothing inside. So nothing inside. So that just bracket with nothing in it. Or it can be denoted by something like that one. So in an exam that if you see that kind of item, you know that one is an empty set. Or so you can conclude and say B, and then that way that one represents. So B is an empty set. B is an empty set. B is an empty set. Now for those items, I think to measure something, you have known that a set is a collection of items, and those sets are separated by comma within a bracket. And then we have also see the measure of number of items in a set, and those and that one it refers to us as cardinality, and it is denoted by 2 vertical line. It is denoted by 2 vertical line. Also, we are talking about empty set, and we have said that an empty set is a set with no element. So it is denoted by 2 items, either 2 brackets with nothing inside, or this form, this symbol here. Also, that symbol represent an empty set. Let us see importance of a set. So importance of set theory. So importance of set theory. Sijui kama itatoshea hapa, but we can try. we can try. Let us see. So important of set theory. So importance of set theory. Importance of set theory number one, and we say it provides a logical language. It provides a logical language in which ideas of the company can be communicated. Let us write that it provides a logical. It provides a logical language. Provide a logical language through which business idea. Through which business idea and the concept can be communicated. And concepts can be communicated. So it provides a logical language through which a business idea and concept can be communicated. So that one is one of them. So it provides a language through which ideas within a particular business can be communicated from one person to another. Number two, next, it acts as accounting method. In which real numbers real items can be counted. So it acts as accounting method from the word count. So it acts as counting method. It acts as counting method in which real numbers real items in which real items can be counted. In short, it aids in counting. So in short, set theory help. So important of a set is used in counting. And then the last one, another important, it provides solid foundation. So it provide solid foundation required in understanding probabilities. Required in understanding probabilities. So it provides a solid foundation. So it provides a solid foundation that is required in understanding probabilities. That is required in understanding probabilities. So I want to do away with the board. I hope umeandika. So it provides a solid foundation required in understanding probabilities. Required in understanding probabilities. Okay, and make sure you screenshot kama ujaandika. And then I want to rub so that we can do another thing. So hopefully umeandika. So let us continue. Let us continue. So we have done important of set. Let's talk about something here: union, intersection, and complements. So union, intersection, and complement. So union, comma, intersection, and complement. Complements. Now, when you talk about, let us say something. Let us have something so that you can explain. So let us write something. So this one is complements. This one is a complement. So let us write something. I hope it is visible. Hopefully it is visible. Let us write something and we say, given set A, and universal set U, comma, the set of all elements in U, the set of all elements in U. U is the universal set. So the set of all elements in U that do not belong to A, that do not belong to A, is called a complement set. It's called a complement set. It's called a complement set. Donated by A with something happen. Now, if we have our universal set, so if we have our universal set, now our universal set is a set that contains all the elements. Now, then you have a particular set A. Now, the set of all the elements in U that don't belong to A, that kind of a set is called complement. We shall do an example. We see. So any items which does not belong to U, but belongs to A, becomes a complement. Okay, tutaangalia na swali. We shall also look for another definition baadaye. Let us also write something here also. Now another one here. Given set A and B, the set of all elements, the set of all elements belonging to both set A and B, belonging to both set A and B, belonging to both set A and B, are called intersection. Are called intersection. Now, if we have two elements A and B, and all the items in A are also in B, so those items that are in A and also in B, those items we can call them intersection because they're intersecting, they are common in A and B. So when you have a set where all elements belong to A and also belong to B, so those items which are common in two types of sets, so those kind of a set, we are calling them intersection. We are calling them intersection set. Okay, another statement before to open examples. So we have another statement here, which says the set of all elements, the set of all elements belonging to set A belonging to set A or B or both sets are called union. Are called union set. Are called union set. This one is intersection set. This one is complement set. So we have complement set, intersection set, and the union set. So union set refer to the set belonging to A or B or both sets. So union as a whole. So a set of all elements belong to set A or to B or both. So ukicombine ziko kwa A zote na ucombine kwa B zote, ukizicombine zote we call them union. So the combination of the two is the union set. Now this one is written as, so donated, so donated as A intersection B. So they are intersecting. So A intersection B. So A intersection B, make sure you write this one.
It's theory na ngori.
A
Theory huko. Sina sup kwa unit niliiba. Sikusoma. Mimi sikuisoma. Theory inakuanga. Isi accounting.
A intersection B. And then for union, A union B, donated by
We can't
A.
see your screen. Excuse me.
Yes.
We can't see your screen.
Oh, okay. Let me see. What about now?
It's okay. It's okay now.
So divided by A union B. So I talk about union. So every item in A, we combine it with B. So it becomes a union. So A union B. So the union set. Let us work with the examples. Let us now work with the examples. So these are the example illustration. So we can write it here. Illustration. So if we can see the word illustration, make sure your phone is not tilted. Given universal set as follows: 1, 2, 3, 4 mpaka 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So given U is equals to, so you have those elements inside: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then A is given as, so A 1, 3, 1, 3, 5, 7. We have B given as 3, 4, 5, 6, 3, 4, 5, 6, 8, 10. So 3, 4, 5, 6, 8, 10. And then also we have C as 2, 4, 6, 7, 8. So given those 3 items, so we have universal set divided by U. So it contains all the elements. Then you have set A, set B, and set C. Required number 1. Required number 1. Find A na something hapo juu. That one is complement. So you are supposed to find tunaanza na ya kwanza hii complement A. Complement of set A. A complement of set A. So what is the complement of set A? Now we said here that given a set A and universal set U, so given set A here and universal set U, the set of all elements in U that do not belong to A is called a complement. Now we have set A and we have U. So which item do not belong to A? So which item are which items of which are in A do not belong in U? So which are those items? So mniambie hizo items kulingana na our definition. So which items? Number 1. So the first item.
2.
Yes.
2.
2 as the first element. 2. Another element.
4.
Yes.
4.
We have 4. 4. Another element.
6.
Yes.
6.
6. Another element.
8, 9, and 10.
8, 9, and 10. So this is the answer: 8, 9, and 10. That one is number 1. So that's the complement. So we are saying the sets of all elements in U that not belong to A. So any item in U but does not belong to A. So we have seen we don't have 2, we don't have 4, 6, 8, and 10. Let's go to the next one. Next. B complement. Now B complement, what will be the answers? B complement. The first one.
1.
1 followed by
2.
2 followed by 7 and 9.
7 and 9, yes.
7 and 9. So those are all about complement. Let's go to the next one. Number 3. A. Now A union B. Okay, not union. Let's go first to what? Intersection. So A intersection B. So A intersection B, let's read. Given set A and B, the set of elements belonging to both set A and B are called intersection. So we are looking to common items. So what are the common items here? A and B. So common items
3,
3 and
5.
5. So 3 and 5 are our common items. So that's our intersection. So those are intersection. Let us go to number 4. A union B. Now A union B. Let us read here. The set of all elements belong to set A or B or both are called union. Now, what will be our union set A and B? What will be set A and B? So it will be all the items, Silvio. It will be all the items. So all elements belong to A or B. Remember, you're using the word B. We are using the word or. Kumaanisha kila kitu yenye kwa A utaunganisha na kila kitu yenye iko kwa B to form the union set. So utachukua hii yote na huu yote. So ya kwanza ni 1, next ni 3, next tuko na 4. Kila kitu unachukua ni kila kitu. So we have 1, hata kama hakuna 1 still ukiunganisha itakuwa ni union belonging to A or. The keyword is the word or. So kumaanisha kama iko hapa na iko hapa, it will form a union because of the word or. So we have 1, 3, 4, we have 5. We have 5. Do you have 6? Yes. We have 6. Do you have 7? We have 7. Do you have 8? 8. Do you have 9? Hakuna 9 kwa zote mbili. So hakuna 9. So 10. So that is all. So every items. So unachukua zote za A na zote za B. Na usirudie kama 3 ziko kote mara mbili. So you have 3 here and you have 3 here. Unaweka 3 moja. So hapa 1 ni moja, huko 2 ni moja. 3 iko hapa na iko hapa. So unaweka 3 moja, usiweke 3 mara mbili. Just one because they are common items. Okay, that is A union B. Now, munifanyie hii. A complement intersection B. A complement intersection B. Someone to do. So niwape dakika kama ngapi? Niwape dakika 2. Tuseme sasa ni 45 ikifika na 47. So A complement intersection B. A complement intersection B. A complement okay. Your answers. Unaweza type tuone kama kwaje. So the first thing you need to find. So the first thing you need to find is a complement, and you have it here, pale juu. So we have 2, 4, 6, 8, 2, 4, 6, 8, 9, and 10. And you need to compare it with B. Our B, ndio hii hapa. We have 3, 4, 3, 4, 5, 6, 3, 4, 5, 6, 8, na 10. Now we compare the two. So the intersection. So the intersection are the common ones. So what are the common items? So we can conclude and say the answer will be equal to, so common. So the common items. So we have 4. We have 6 as common items. We have 8. We have 8 and 10. So that is the answer for that one. 4, 6, 8, 10. So intersection means common. So intersection also means common. So zinafanana. So intersection. Haya, kuna ingine hapa. Kuna ingine hapa inasema A intersection B, U, and C. So A intersection, and then B iko wapi? B union C. B union C. So what would be the answer for that? So hapo inaonekana isikuwe ninaandika vitu zangu. So kitu ya kwanza, you need to find B union C. So you need to find B union C. Now we have our B here and we have our C here. So all the items zitakuwa zote. So tunaanzia na gani? So B union C tutaanzia na penda kwanza hii B union C. We have 2 as common hapa, followed by 3. We have 3, yes. 3. In short ni items zote ziko kwa B na C. So tukiongea B union C tunaanza na hii kwanza hii hapa. So ni kumaanisha ni items zote ziko kwa B na C. So tuko na 2, tuko na 3, tuko na 4 ni common kwote. I think tuko na 5. 5, tuko na 6 pia. Tuko na 7, tuko na 8. Tuko na 8. Tuko na 8, 9. 9 hakuna, but we have 10. Now this one you compare with A. You compare with A. Our A is 1, 1, 3, 5, 7. 1, 3, 5, 7. So what would be our answer? Our final answer? Our final answer, tuambie. So A intersection, B union C. So the common items.
3,
So what are the common items?
3,
3,
5,
3, 5, and
7,
and 7.
and 7. Yeah.
That one is fine. 3, 5, and 7. So that is the answer for A intersection. Then B union C. Then B union C. We have another one here. Niwape assignment. So this will be your assignment. In case you need the answer, mtaniambia. So assignment ni continuation ya hii swali yetu. So ilikuwa mrefu. So ilikuwa ni mrefu. So continuation. So assignment. So number 6. Number 4, 5, 6. Number 7. So number 7, A union B intersection C. And then 8 A intersection B, and then C complementary. C complementary. So those are your assignments. Those are your assignments. So you only have 2 assignments there. So those are your assignments. Now let us go to our past paper. Let me present. Let us go to our past paper. Let us go to past paper. We see what was the requirement. I'm trying to find a way on how to I want to share the screen. Just a moment. Just a moment. Hopefully now I can share. Okay. Now, let us see. There was a question that was tested in April 2024. There was a question that was tested in April 2024. There. So given the following sets, screenshot the question because I'm going to do away with the sharing. So, but I'm reading. So given the following sets, we have set A.
That's
B.
question. Sorry, question. Which
C.
question?
That is the question for April 2024.
Number?
Number 1C.
Okay.
It was on last sitting.
Tower.
Yeah. Now, can you see the board? Can you no? Can you see the question in the screen?
Yes, we can.
So kama mnaona ni better, you can write it down. Nikisoma. So the question reads that given the following sets, so we have A, B, and C. Required number A, you find the universal set. So remember, universal set is the set containing all the items. Remember, the set containing all the items. Number B, A intersection B intersection C. And then you have C complement. Then you have C. You have C complement. You have C complement. Let us go back to our board. Let us go back to our board. We go back to our board. So we go back to our board. So this is our question. That one is for April. April 2024, question number 1C. Number 1C. So given A, B, C, and D, then you have B, C, D, E, F, G. Then you have C, H, I, J, C, and D. So number 1, you're supposed to come up with the union set. So union set in capital U. Capital U. So capital U. Make sure ni capital U without aina hii kakitu. Aina hii. So this one is not universal. Ukiweka hivyo unaongelea mambo na union. So ukiweka hivi unaongelea mambo na union. So U, universal U with U. Like this one here, U. U. Okay. Let's see. Now, when we say union, so we are talking about all the items. Let us start with the first one. To kia zote, we have A, B, C, D. So D, hapa kuna inaendelea. C, D, we have E, F, G, we have H, I, J. Kuna ingine? I think imeishia hapo. So that is the universal. So all the items, tukiziweka pamoja, we are going to categorize it as universal. We are going to categorize it as universal. Then we have number 2, A, intersection B, intersection C. So which are the common items in A, B, and C? Common items in A, B, and C. Naona kuna C. C na D ndio common actually. C and D. C and D only. C and D only. Do you have any other common item hapo? So C and D kwa A, C and D kwa B, na C and D kwa C. So I think those are the only common item. And then the last one, we have number 3, C complement. Now C complement, you compare C with the universal. So you compare C with the universal. So all the items in U, not in C. There you are. Let us go to complement. Given set A and the universal set U, the set of elements in U does not belong to A. So set of element in U that do not belong to A. So hapa set in U that not belong to C. Now the compare is our wili. So we have C na U. So all item in U that not belong to A. That don't belong to C. So which item are in our universal set here, which do not belong to C?
A,
Moja.
B,
Yes. A,
B,
B,
C, D, E, F.
E, F. E, F.
G. Yes, G.
G.
Yeah.
At that point. So that is
Yeah,
that's how you are supposed to answer that question.
D.
Yes.
Hakuna D. Hakuna D.
D.
We have D in U.
D. Au
We
yoni
have
hapo.
D.
Iona.
D iko kwa both C and U.
Iko. Oh,
Oh,
tunafanya kazi
sorry.
gani hapa? Turudi AB. Oh, C and D hakuna. Tutoe C and D. And then E.
A, B, E, F, G.
F,
G.
G, back hapo. Oh, C and D haikukua. C and D. So that's how we're supposed to answer that question. That one was for last sitting. There's no any question appearing on sets apart from last sitting. So the other ones are definitions. You are supposed to define what is a union set, what's a complement. So remember when someone tells you to define what's a complement set, you just use an example that when you have, so you can say it is a set where the set of all elements in the universal set do not belong to a particular set. And then you do it by we shall let us continue, but we shall look for a good definition as we continue. We shall look for a good definition as we continue. Okay. Type of sets. Let us dive in to type of sets. Type of sets. So type of sets. Where is that stuff? So type of sets. Type of set number one. Number one. Empty set. Empty set. What do we say? Is a set with no element. So a set with no element. Example, i.e., a particular set, the bracket is 0, or A divided by that one. So that's the example of an empty set. Number two. Now, let us say something here. Cardinality of empty set is given as follows. Is given as follow. Now, this is how you give it. N, and then 0 or. So the number of items in that is 0. So you can use the vertical lines of A in 0, the measure of number in a set. I'm going to say N into bracket A equals to 0. Either of them. Number two, we have singleton set. So a set with a single item, element. So a set with one element. So a set with one element. Single, from the word single. I think inaonekana. Okay. So a set with one item. And then you can say, example. So you can have 1, ama 2, ama 3. We can put anything. Together, what are 4? So it only have one element. Cardinality for this one. Cardinality for singleton set is given as follows. So either uandike n a, it has one element, or a has one element. So that's how you write cardinality. So the measure of numbers in a set. You have number 3 as finite set. Finite set. Finite set. Set a set with limited element. A set with limited element. So i.e. A has the following items. And then you can also write cardinality. So that's an example for finite sets. It got a number of sets which you can count. So finite, you can easily count the number of sets. So cardinality will be equal to how many sets? So we can count 1, 2, 3, 4, 5. 5 or 5. We move forward. We have what we call infinite. Infinite set with a limited element. We cannot count the number of elements. A set with unlimited element. So a set with unlimited elements. So a set with unlimited elements. Then you can say A is equals to 1, 2, 3, 4. Then haina mwisho. So haina mwisho, it doesn't have an end. So it can be 1 to 1 billion. So it can be 1, 2, 3, 4, 5, 6, 7, backup billions, trillions, and so on. Haina mwisho. That is all about finite. Number 5. Talk about equal set. Equal set. Equal set. Equal sets. What are equal sets? So 2 sets are equal. 2 sets are equal. 2 sets are equal if they have same element. If they have 2 elements. So two sets are equal. 2 sets are equal if they have 2 elements, i.e., let us use this one. Set E is a letter in word earth. So we can say E contains those elements earth. So that's that was number one, and then we have another set. Then we have another one. Set H is a letter in a word heart. Heart. Then you can say H contains H, E, A, R, T. Now, set E and set A, H are equal. Set E and set H are equal. Why are you saying are equal? Because all the elements in set E are also in set H. Look at, do we have E? E equal A, yani A inaapia pia hapa. A inaapia. R inaapia. T inaapia. H inaapia. So every item in E iko pia kwa H, regardless of the arrangement or sequence. So regardless of zimearrangiwa hata kama zijafuatana. So because sets zote ziko na the same letters, hata kama zijakuwa arranged in a particular manner, then those two sets are assumed to be equal. So it's an equal set. Ama unaweza nyingine, or ukiwa na set hii 1, 2, 3. Now you have B. We have 2, 1, and 3. Regardless of arrangement, A equals to B. So they are equal. Na hapa tumesema E equal to H. So set E equals to H, regardless of the arrangement. Regardless of the arrangement. Let's go to the next one, 6. Equivalent set. Set with the different elements refers to set with different elements. Set with the different elements, but have same number of elements. But have same number of elements. But have, nimeenda sana. So set with the different elements. Set with the different elements, but have same number of elements. But have same number of elements. But have same number of elements. We can give example. i.e. we have set F given us 1, 2, 3, 4, 5, and set E. Set E given us inaonekana. Acha nirudi kidogo huku. Then you have E divided by so tuko na hizo mbili. So we have F and E. Now ukiangalia those two sets ziko na different items. So ya kwanza iko na numerical, ya pili iko na inaitwa ni letters. But the element inside is the same number of elements. Ukiangalia hapa ni 1, 2, 3, 4, 5 na ukiangalia chini number of elements 1, 2, 3, 4, 5. Now, because they have the same number of items inside the bracket, we consider them as equivalent set. So we consider them as equivalent set, i.e., so you can say n into bracket f is 5. We can also say n e equals 5. So the number of items inside the measure cardinality equals 5, and therefore we can conclude they are equivalent. So we can conclude the two are equivalent set. So the two are equivalent set. So the two are equivalent set. Number 7, let us add two universal set. Universal set related by U. Universal set related by U is a set containing all elements. Is a set containing all the elements. So the sets are set containing all elements, and which all other sets are subset, and which all other sets are subsets, and which all other sets are subsets. Tunasema refers to a set containing all the elements in which all other sets are subsets. Okay, I think that one is fine. And we can give an example. Let me do away with this part, tulianzia, so that we can give an example. I want us to give an example of a union set. So union set example. So you have this union set A, E, O, U. Then you have set element here A, I. We have another one here B, as I, O, U. Now, if you take A and B, so all items in A and B are also in U, and therefore that one is categorized as a union set. That one is categorized as a union set. That one is categorized as a union set. So all the items in A and B will form the union set. Let us talk about subsets. Okay, subset as our next item. Subset. Set A is a subset of set B is a subset of set B if and only if and only if every item in A are also in B. Are also in B. So a set A is a subset of B. So a set A is a subset of B if and only if every item in A is also in B. Divided by, so this is so donated by so A subset B. A subset B. So A subset B. Example, i.e., we have A has these items CI and R, and then required list or possible subset. List or possible subset. Now, number one, the first subset is this one will be equal. This one will be the first subset, S, I, and R. So the item itself is a subset of itself. So the item itself is a subset of itself, and then we write A, not A. Let us do this. A set is a subset of itself. So you're number one. So the set itself can be a subset of itself. A set itself can be a subset of itself. Number two, we have this one, S. Then we have another one here. We have I, and we have R. And then you can say set with one element. Now, each element, when we take each element alone, it will be a subset of the bigger set. So when you take each item alone, it will be a subset of the bigger set. So the first one, this element S is a subset of A because it is an element inside. So any element inside also form a subset of the set itself. Number three, we have two items at a time. We have S and I. You can also have I and R. You can also have R and S. And then you can say set with the two elements. Set with the two elements. So when you take two elements, from the set, it will becomes the subset of that set. So ukichukua any two elements from the set will become the subset of the subset of the element.
I think they fall under a spell on a stretch, but been a little bit starved of possession.
Okay.
In the last 15 minutes.
And then the last one, another possible subset we can have is empty set. Now, an empty set will become a subset of the set. So empty set. Empty set. So that is also a possible subset. So when we remove all the items from A, Then we have an empty set. That empty set is also categorized as a possible subset of that set. Okay. So we have done cardinality, and we have seen cardinality is the measure of number of items in the set, and we have donated how to use it. So another one we want to see, I think we can talk about proper subset. Proper subset. Can those be asked in an exam? Proper subset.
Fascinating. We have been 27 minutes.
Okay, let me see. Let me see the first, the most important item first. I want to see the most important.
Pretty much since then,
Uh-huh.
both periods of dominance, I need that to create a real opportunity to score a goal.
Let's
There's
see.
a gridlock here at the moment. You've always going
Okay, let us, let me see. Mm-hmm. Let me see. We can look about, we can talk about this joint set, this joint, any common, that one is.
You spoke about the man for the big occasion, and he has just delivered again. I mean, it's a lot clearer from Cookery, a lovely touch from Woodbury, and then it's all about final movement. He makes sure he keeps himself onside Morata. He knows he's being chased down by not one but two Croatian defenders. Can he stay composed? You bet your life.
Okay, wait a bit. I'm coming back.
Into the corner of the net, actually the garbage. And pretty much against the run of play at the start of the ball for 10 or 15 minutes, but it only takes a second. Alvaro Morata.
Okay, let us continue. Let us continue. So I was talking about this joint, here called overlapping. Not overlapping. This joint, not overlapping. This joint set. This joint set, and we say two set A and B are this joint. are disjoint set if they have no common element. If they have no common, if they have no common element. So A intersection B, you can say no common item. Example, let us work with an example. A is given as 135, 135. B 2, 4, 6, 8. Then A intersection B. What will be the answer? So that is a disjoint, meaning there's no common item. Meaning there will be no common item. So what will be the answer? Now, because there is no common item, then this will be the answer. So no common item. So that is a disjoint set. Okay, let us talk about overlapping set. So when we don't have any common item, then that one becomes disjoint. Let's talk about overlapping. 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 Overlapping set. So set A and B are overlapping. So set A and B are overlapping if they have at least one element in common. If they have at least one element in common.
Niko class poa, niko class.
So that one is all about the overlapping sets. So set two sets. So set A and B are overlapping if they have at least one common, at least one item in common. At least one item in common. When we can say this one A is equals to 1, 3. So 1, 2, 3, 4. And B 2, 4, 6. So we can say, so at least two common items, which is 2 and 4. So the 2 and 4 are overlapping. So hizi ni kama tu zile tumefanya kule nyuma, intersection and so on, as overlapping. So we shall start from Venn diagram. Ama tumalize Venn diagram leo, tumalize kabisa. Suggestions? We can decide to finish the Venn diagram and we do some question like 2 question or 3. Ama tufanye kesho majioni.
Kesho jioni.
So we meet from tomorrow. So our topic, this will be our topic. Let me write it here. So make sure you check
Continue.
our past paper. There's something I want to share with you. Sijui niwatumie
Hapa.
kwenye wacha niwatumie kwa saa hii. Kama naweza kufanya saa hii. But let me check if I can manage. You go with that, do that one. So Venn diagram. So Venn diagram has appeared quite much in the past paper. So we shall have a lot of questions from Venn diagram. So we shall do at least 3 questions. So from Venn diagram. Now there's this PDF. Let me show you. And then you tell me if you want it or not. So I also have for function, I will share with you later. Now we have this PDF. Do you have this one, guys? So we have the definition of a set, importance, type of sets. You can see we have empty set, we have singleton set, equal set, we have disjoint set, we have universal set, we have subset set, we have complement set. Then we shall start from operation of set. That one is from Venn diagram tomorrow. So we have operation of sets and then some question from our past paper. Should I share the question, the PDF?
Yes, please.
Okay. Now that one marks the end of our class. So let me share now. Before mtoke ona niambie kama umereceive. Sitaki nitoke nisisahau. I'm sharing now. Kama ni wait. Let me see. Kidogo tu nione kama nini yangu inafanya. So but with that one, I think we have done a bit. So I want us to finish tomorrow Venn diagram, so that we introduce matrices. And we do also some question in our past paper. So I hope everyone can do any question when it comes to functions. Those questions of revenue and cost functions, revenue function, profit function, maximization of profits and revenue, and any other kind of situation that involve function. And then for function, not for function. For set theory, you just need to remember the definitions. So you shall look for the definition from this new PDF that I'm sharing now. So once I share that PDF, you shall have other definitions in your member Japiana. You shall check for the definitions, and then tomorrow just come and do Venn diagram, and we explain some basic concepts that we need to know before you do any question in a Venn diagram. So what is the procedure that is most suitable to follow when doing a Venn diagram? So we have a lot of questions in our past paper concerning that one. Also, I want you to go and research these items. Go and research items on proper subset, of which sijui kama zinakuja kwa exams, sijawahi ona. Proper subset, and then you have a power set, proper subset, proper superset. So we have proper subset and proper superset. proper superset and power set. And power set. So make sure you try those, make sure you find those 3 items. So nimesema proper subset, proper superset, power set, na superset. Na I think superset. So we have proper superset with superset, power set, and then proper subset. Proper subset. Okay, let me share. Let me see if it is here. Kidogo tu. Supposed to be where? I think hey, I cannot find it. I think I will share with you later. Oh, here it is. So have you received it from the group? So nimetuma hiyo. I hope we receive. That one marks the end of our class. So good night. See you.